All right, welcome to part two of topic number 28, solving exponential and logarithmic equations. So here we finished the exponential equation. So we're going to take a look at how we can solve logarithmic equations. All right. So some of the properties that we learned before, okay, will actually come in play here. All right. The property of logarithmic equality. This is actually something new. What this one is saying is very much is like the base exponent property. Basically, if you have a log with the base a of something that is equal to base a of something else, when you're taking a log of this with the same base, okay, if the log is the same and the base are the same, then what we can do is set what they are of equal to each other. Okay, we will use this little thing here in a minute. All right. Changing logarithm basis, we actually learned that before. Okay. Convert between exponential equation to log equation. We've seen this before. We will actually use it again. All right. So the only thing new is number one, this thing called property of logarithmic equality. We will actually see that we might run into an example using that technique. All right. We will also need the technique we learned from the log of product, log of quotient, and log of power. All right. Those will still come in play. So I remember showing, I remember talking about condensing, okay, condensing the logarithm. We will actually, we will actually use some of that, that technique here also. The condensing part of your logarithm is basically your log of product, quotient, or power. All right. So here we go. I'm going to show you a couple of examples, okay? These three examples I have are two terms, okay? All these are two terms only, okay? So they're a little bit easier, but they are very important, especially this very first one. This first problem right here, the way we actually solve this logarithm is, again, if you only have, if you have two terms, but only one term has a logarithm, okay, then what you got to do is turn this problem into exponential. So you actually have to apply convert between exponential and logarithm equations. Okay, this is very specific. This type of problem is very specific. If you have two terms, one term has log, the other term do not, then the only way to solve for this problem is turn this logarithm equation into exponential. So I'm going to move my base to the other side of the equal sign. All right, so there will be 2x minus 1 still equal to 3 to the fourth power. Right, bring the base over and bump the 4, whatever's on the other side, to the exponent. All right, now I'm actually solving for a linear equation. So 3 to the fourth power. If I actually put in the calculator, 3 to the fourth power is 81. So this is 2x minus 1 equal to 81. Move the negative 1 over, that become positive 1. So 81 plus 1 is 82. Divide both sides by 2, my answer, 41. Okay. Now, this example right here, I'm gonna write this on the side. You don't have to copy this down if you don't want to. Remember, natural log is a logarithm with the base e, right? Natural log is the same as log with the base e of ax minus 7 equal to 14. So again, so basically, this example is the same as the one on the left. You have two terms, only one term contains a log. So you got to convert this into an exponential equation by moving the base to the other side. Then what you have is ax minus 7 equal to e to the 14 power. Move the base to the other side and bump this 14 to an exponent. Okay, that's how we actually convert logarithm to exponential. Just bring the base over and whatever's on the other side of the equal sign, they go up to exponent. All right, so this part is going to be exactly the same as if I would say, all right, here I have a natural log. So what I can do is take an e on both sides. Remember, when I take an e on both sides, okay, it's not e times natural log. It's actually e raising to the natural log of ax minus 7 equal to taking the e on both sides, so that will be e to the 14. And that's actually what's going on. So the e and the natural log will cancel out. So you end up with ax minus 7 equal to e to the 14 power. All right. When you take an e on both sides, you actually put everything on the exponent above the e. So you see, we still end up exactly the same thing. Okay. Either way you look at it. All right. E to the 14 power is some sort of irrational number. So I'm not going to evaluate that yet. Okay. I'm going to do that at the very end. So I'm going to move my negative 7 over to the other side. So that's ax equal to e to the 14 plus 7. And divide both sides by 8 or every term by 8. I can say this is x equal to e to the 14 plus 7 divided by 8. And of course, I can go to my calculator and evaluate what that is. All right, run to 4 decimal place. So I'm going to do second e to the 14 power, close parenthesis, plus 7 first, right? That's the numerator. Then I divide it by 8. Okay, so I get this big old crazy number. That's your decimal approximation. So a lot of times we just leave our answer as an exact answer. Okay, most of the time we don't really do too much with it, with these irrational answers. All right. Now this example, you see two terms again, but both term has a natural log. Both term has a log. So we can actually use this very first property of logarithmic equality. What I mean is when the natural log, when the log are the same, then the base are the same, right? Both of them using base e. Then I can set what they are of equal to each other. So then all I end up with is x minus 5 equal to 2x. Or if you want to say, all right, take an e on both sides, right? Because both of them had natural log. If you take e on both sides, then eventually natural log and e will cancel out. You still end up with x minus 5 equal to 2x. All right, move the x over. So that'll be x equal to negative 5. But you got to be very careful if you actually say, all right, natural log of negative 5 minus 5. That actually is not a real number. Okay, remember, we cannot take a natural log of a 0, take a log of a 0, or take a natural log of a negative number, or logarithm with a negative number. So technically, this problem has no solution. That's the reason why, because you end up, if you plug the number back in, you actually end up with negative. All right. See this 41 we had earlier? If you plug in 41 back into x, okay, I'm not going to take a logarithm of a negative. So 41 is my answer. All right. Now, these problems, okay, has 3 terms. Okay. These two next to example have 3 terms. When you have multiple logarithm terms, okay, when you have multiple logarithm terms, what you can do is condense them, okay, back into a single logarithm term. All right, both of these are the same type of problem, but I want you to see this. Okay, the very last one. See, the very last one, every term has a logarithm. All right, so we can actually condense each side of the equal sign and then go back and apply this property of logarithmic equality. However, these two examples, there is actually one term that does not involve with log. So whenever you have multiple terms, right, more than 2 terms, and if one of those terms does not contain the logarithm, then we have to use the concept of condense all the logarithm into a single term, and then we can apply the convert between exponential and logarithm. We need to convert logarithm equation into an exponential. Okay, so there's a difference between some of these problems. It's all because this one term does not contain logarithm. All right, so this example right here, I'm going to condense these two logarithms into one single logarithm. So the subtraction tells me when I condense them back, it will be dividing. So right away, I should get log with the base 4 of x plus 2 over x minus 4 equal to 2. And from here, I will use the concept of convert between logarithm and exponential equations. So moving the base to the other side of the equal sign and bump the 2 to the exponent. So what I got myself here is x plus 2 over x minus 4 equal to 4 squared. All right. Now 4 squared is 16. So I'm going to go ahead and say this is x plus 2 over x minus 4 equal to 16. To solve for x, I'm going to use cross product. So I'm going to go ahead and write 16 over 1. All right, 16 times those two terms, 1 times those two terms. So 16 times x minus 4 set equal to x plus 2 times 1 is still x plus 2. Distribute 16x minus 16 times negative 4. It's going to be negative 64 equal to x plus 2. I'm going to move the x over to the left side. That become minus. Move the negative 64 to the right. That become positive. So this is going to be 15x equal to 66. So 66 divided by 15. If I reduce my fraction, I should end up with 22 over 5. All right, 22 over 5 is 4.4. So if you take this 4.4, plugging right here where it says x minus 4, you will still be okay. All right, so my answer is legit. All right. Now, this example right here, very interesting. Okay, now I see it now. This term right here can actually be evaluated first. This thing can actually be evaluated first because this term does not contain any variable x. So if I were evaluate this log with the base 3 of 9 here on the side, set it equal to y, right? Set equal to a variable, move the base to the other side. Then now it's going to be 9 equal to 3 to the y power. So 9 is 3 squared. So so my y is equal to 2. So this term evaluated is going to be 2 plus the 2 that's already there. So this example is actually 2 times log with the base 3 of x plus 4 equal to 4. All right. Before I convert my logarithm equation into exponential, let's move the exponent back to the top. Okay, move exponent to the top. Remember, whenever you see one term with a logarithm, the other term is not logarithm, you always convert logarithm into an exponential equation. So I'm going to move my base to the other side. All right, so this is going to be x plus 4 whole thing squared, right? Move the exponent back up to the top, equal to 3 to the 4th power. All right, 3 to the 4th power is 81. So basically what we got ourselves here is x plus 4 whole thing squared equal to 81. So since I only got two terms here, I can quickly take a square root on both sides. So that gives me x plus 4 equal to positive negative 9. I just happen, I'm just lucky. It's just lucky happened that 81 is perfect. It's actually a perfect square number. So I can take a square root on both sides. All right, move my positive 4 over. So what I end up with is a negative 4 plus 9. And the other answer is negative 4 minus 9. Negative 4 minus 9 will give me negative 13. So I know that answer cannot work. So my answer, x equals positive 5. See, if you plug in positive 5 back here, it will be still positive. Give myself a little bit of space here. All right, this example, see there's one term without logarithm. All right, so what I want to do is condense. All right, I got 3 term with log. Let's take a look at the very first sign. This plus sign means we will multiply these first 2. All right, so that would be log with a base 2 of x minus 6 times x minus 4, right? Then the next sign is minus. That tell me I gotta divide. Whatever I have on the top will now divided by x. There you go. That's how we convert back into a single logarithm equal to 2. All right, one logarithm term. The other term is not. So let's convert this into exponential. I'm gonna move my base to the other side. So I got myself x minus 6 x times x minus 4 over x is equal to 2 squared. 2 squared I know is 4. All right, so to solve for x, I can use cross product again. So I'm going to write 4 over 1, and I'm going to use my cross product. All right, 1 times those 2 are still x minus 6 times x minus 4. 4 times x is equal to 4x. The left side, I'm going to FOIL this real quick. The first thing I do is x times x, which is x squared. The last thing I do is negative 6 times negative 4, which is positive 24. All right, let's see what my inner and outer is. My outer is negative 4, inner is negative 6. Negative 4, negative 6 combined, give me negative 10x in the middle, equal to 4x. All right, so here I got myself a quadratic equation. So I'm going to move my 4x back over. So that becomes negative 4x come over. So that'll be negative 10x minus 4x, negative 14x plus 24 equal to 0. 64, 24. For 24, I'm going to try to factor this. X and X, 24 can use 2 and 12. All right, since last sign is positive, the sign for the 2 parentheses are the same. Both of them got to be negative because I need negative 12, negative 2 combined to give me negative 14 in the middle. All right, set each factor equal to 0 and solve for X. So move the negative 2 over, move the negative 12 over. So here I got 2 answers, but if you look at this answer 2 and plug it back in, 2 minus 6, 2 minus 4 will give you negative. You'll end up taking a logarithm of a negative, so that answer cannot work. So my answer got to be x equal to 12. All right, one last one, okay? This one, all the term has logarithm, okay? So what we can do is go ahead and condense them. This subtraction sign means we'll divide. This subtraction sign means we'll divide. So natural log, so this left side is natural log of x minus 2 over x plus 3 equal to, the right side is natural log of x minus 1 over x plus 7. Right? Every term has natural log, so we can condense each side. So when the log are the same and the base are the same, we can set what they are of. Right? Natural log of this, natural log of that, we can set what they're of equal to each other. So that's applying this property, the property of logarithmic equality. All right, let's use a cross product to solve for this. X minus 2 times x plus 7. So that equal to x plus 3 times x minus 1 All right, I'm gonna FOIL this real quick. Okay, x times x is x squared. Negative 2 times 7 is negative 14. All right, outer is 7, in there is negative 2, so that should be positive 5x equals x times 6 is x squared. Positive 3 times negative 1 is negative 3. Outer is negative 1, inner is positive 3. Okay, 3 minus 1 is positive 2x. So this is not quite a quadratic equation yet because I see positive x squared on the left, positive x squared on the right side of the equal sign, so they automatically cancel out. So I have myself a 5x minus 14 equal to 2x minus 3. All right, I'm gonna move the 2x over, move the negative 14 to the right. So that should be 5x minus 2x equal to negative 3x, I mean negative 3 plus 14. So that should be 3x equal to 11, x equal to 11 over 3. There you go. All right, let's take a look at some homework problems. All right, question number one was from the, question number one is actually from the exponential equation. All right, so what I want you to do first is take a natural log on both sides. For this problem, I want you to take a natural log on both sides. So that example is very much like this one, very much like that one. So when you take a natural log, the trickiest part is this. When you take a natural log on both sides, okay, 3 times e, 3 times e to the 2x plus 1, right? So this multiplication, so when you take a natural log of the left side here, multiplication telling you that that will actually split up into two terms. So that multiplication becomes a plus, right? And that plus is right here. This second plus here from the hint is actually this plus right here. That plus and that plus are the same one. Okay. So I want you to take a natural log on both sides. And when you take a natural log, what happens? The exponent comes down, right? So split this 3 times e to 2x plus 1. And then natural log of e to the 2x plus 1. Natural log and e will cancel out. So 2x plus 1 naturally come down. And once you have that, then I want you to move all the variable term to the right side. Okay. Move all the variable term to the right, everything else to the left. There is a 4 over 4x over 3. So I want you to multiply every term by the LCD, which is 3. Do that, then factor out the x. Remember, the reason why I have all the variable term on the right side, so I can actually factor out the x before I divide both sides by the coefficient. All right, so make sure you, so your answer will look something like this. Question number two is similar to the one I just did. Similar to this one right here. This one right here. All right, condense the two terms on the left, the two logarithm on the left, condense them, set it equal to 2. Then what I want you to do is bring the base to the other side, okay, and then bump the 2 to the exponent. Then number 3, I want you to evaluate what this is and put it right here. Okay, well, evaluate it, what it is, and put it right there. Then on the side, I want you to perform, well, excuse me, then number 4, I want you to perform cross product. So once you evaluate what that is, that is over 1, perform a cross product, but you don't have to evaluate. Don't multiply. Excuse me, don't do any distribution. Just write it out. Just write out your cross product, and then solve for x. So earlier, where was it? Early right here. Earlier when I said perform cross product, all I did was roll it out. That's what I mean by that. Roll it out first. Then the following step, you can actually solve for x. So number 4 is actually, you know, once you perform cross product, just write it out first. So I know that you know, something gotta be distributed, right? This term gotta distribute both those. So write it out first. Let me show me that you know those two terms gotta be in the parenthesis So when you get to solving for x, you know to distribute and solve for x. All right, so I know this video is a little bit long. Okay, both videos are a little bit long together, but I just want to show you how you can actually solve exponential and logarithmic equation. All right, thank you for watching.